Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azul Izzat. Metric number B0518100015, and two of my friends, which is Muhammad Kamil, Muhammad Sari, B0518100030, and Khairul Shakir and Khairul Munir, B0518100011. Today we are going to explain about the three axes involved when analyzing a dynamic problem. The first one is the rectangular axis. When a particle moves, we can analyze it using rectangular coordinates, which is x, y, and z coordinates. The force acting on the particle acceleration can also be expressed in the terms of I, J, K components. As you can see from the example given, an apple falls from the tree. In this, we already knew the height of the tree. So first, you can draw the free body diagram of the apple. Drawing this diagram is important since it provides a graphical presentation on all the forces acting on the particle. The direction and sense of the particle should be established. In this case, the axis involved is only y-axis, no x-axis, because it only involves falling down from the tree. Next, we must identify the unknowns. The unknowns right now, in this case, is the acceleration and velocity of the apple. Next, we can apply the equation of motion. So the equation of motion involved is only summation of Fy equals to Ma. Why there is no x? Because there is no x direction involved. Okay, since we can assume the acceleration is constant, we can use the three equation, which is the V equals to V naught plus AD, S equals to S naught plus V naught P, and V squared equals to V naught squared plus 2AS minus S naught. Only use this equation when the acceleration is constant. So by using this equation, you can obtain the velocity and acceleration of the apple by using the x, y, and z coordinates. Okay, for the next axis that we are going to analyze when solving the dynamic problem is the normal and tangential axis. When a particle moves along a curved path, we can use the normal and tangential coordinates to analyze the particle. First, establish the coordinates and draw the free body diagram. These are the coordinates and the free body diagram. The particle normal acceleration always act in the positive direction. Next, we can identify the unknown, then apply the equation of motion. The formula used in this axis are usually A normal equals to velocity squared over rho, and A tangential, acceleration tangential equals to Vs over d, V dV over ds. V is velocity and rho is the curvature, which is the length of the curve from here to the center. This is rho. Once we identify the unknown, and then we apply the equation, and then we can know all the unknowns from the question, from the dynamic problem. Okay. The last axis that we are going to analyze is the cylindrical components. When all the forces acting on a particle are resolved in a cylindrical components like this, allow the unit vector direction of r, theta, and z. The equation of motion can be expressed as summation of Fr equals to MAR, summation of F theta equals to M acceleration theta, and submission of Fz equals to M A Z. As you can see from the diagram, these are the axes involved when a particle moves along a cylindrical path. Cylindrical coordinates requires the determination of the resultant force, which cause a particle to move with a known acceleration. Cylindrical are a suitable choice for the analysis of a problem for which data regarding the angular motion of radian V is given. Once these coordinates have been established, the equation of motion can be applied. So the method to solve this kind of coordinates is first establish the r, z and theta coordinates and then draw the free body diagram. We can assume the acceleration of r, z and theta is in positive direction. Next, we identify the unknowns and then apply the equation of motion so that we can know the unknowns from the problem that we have been given. So that's it. Thank you.